Okay. I think I'm remembering to do everything. Jed, congrats. You got a first. Oh my god. Hope you're doing well, Jed. Not me? Oh. When you said oh my god, I thought you did. Oh. There you are. Okay. Hi, Jed. Congrats on the first. I hope you're doing well. The music is way too loud. I think that's better. Okay. Yeah, thank you. Might still be a smidge loud. Okay. Um, I don't know why that keeps like. I feel like that's been changing. Anyway, um, I had a busy morning slash early afternoon, but the moral of the story is that this code now works. Right? Python code in Greek. There's a lot of Omega sides and news being thrown around. You're right. um, yeah. You know, I actually like when you make plots, you can actually put LaTeX in those plots and it renders just fine. Um, which was kind of cool. No, this is written by me. It's the variable names actually make sense because this is the solution to a partial differential equation. So I'm actually representing values of omega with omega, same with psi. The new is this new here. That's just a parameter. Um, but yeah, what this code does is it numerically solves that partial differential equation. And it finally got the answer that matches the autograder's answer, which I was doing it right. I just wasn't doing it the exact way that they were doing it in class. So I was being marked wrong. But this is what it comes out with. It's like the start of a vortex. It's pretty lame, but they had to like make it simple for the sake of the autograder that like runs your code and checks your variables. Why does it go from 60 to 0, by the way? What the hell? Why? Ooh, I might know why. Do I know why? No, I don't know why. Why? Why? That's so weird. What am I doing the other half? Wait. The other half, like, we're talking like that as the other half? That, or do you mean something else? Well, yeah, but it's the y-axis going uh like why is 60 positive 60 is at the bottom and zeros at the top? Oh, the partial differential. Yeah, it's true, Jed. You know, I should really be solving the total differential equation. Um I don't feel like figuring that out. Who cares? Uh Slim. Done all already? Well, welcome in. I hope your stream was good. I only kind of glanced at it. I've been busy trying to get this code working, and thankfully it finally is. That's in with the meme raid. Thank you so much, Slim, and a grudging thank you to Dessen. um, welcome in. I hope your stream was good. Only math and automobiles split their differentials. True. Ready for Thanksgiving next week? I am. I'm hoping to be able to do a special stream on Thanksgiving, but I need some things to like line up right. Balake, present. I'm about to ask if you are, but I guess if you're in Canada, you're probably not going to celebrate. Ready to get fat after grad food eating? You know, I'm always ready to get fat, just in general. Yeah, that's true. Yeah, you guys have Thanksgiving earlier. Xerxes, hey, I do not do IMO questions. I'm sorry. I don't know how to do them. Yeah, so for everyone who's coming in here, I have this code that I finally got working, and it passed the autograder that runs the code and checks your variables. It gets numerical solutions to, it was called two-dimensional Navier-Stokes or advection-diffusion or whatever. It simulates vortexes, vortices. And I just call them hurricanes because that's more fun. And I think it also applies to hurricanes. Tofu won over pasta. Tofu is great. I love tofu. You have to make it right. So yeah, I've done like all of this part of the assignment, solving the same thing with 5 different methods. I'm on to the kind of bonus part of the assignment that's a bit more fun, where now that we have this working simulation, we're going to give it some crazy initial conditions and just kind of see what happens. It's an easy homework. Oh yeah, you go solve it. Who would win in a fight between a grilled cheese and a taco? Ooh. Tacos are spicier. I feel like that would be a big advantage in a fight. I think I'm going with tacos. Like I feel like grilled cheeses are kind of the nerds of the food world. Like they wouldn't be very, very good in a fight. And that's funny because I've been eating grilled cheese for the past like I had a grilled cheese every day for the past like 6 days, I think. Tofu is just a cooking skill check. True. Yeah, especially if it's Tuesday. Tacos are just a shoe-in. Grilled cheese wins. Ooh. I don't know about that, Jed. Integrals, not IMO integrals, no. I do regular integrals, sure. Did I already show what I have not? I'll show again what this code gets as a visualization. It's just like the start of a vortex. If you let it run for longer, it's actually going to start to like spin around and stuff. We're gonna make some cooler looking ones today, hopefully. So we're gonna start by copying. Do I want to? Yeah, sure, we can copy this. And then I want to rename it as cool as it gets, because that's the name of this part of the assignment. We want to keep all of this stuff. We can, yeah. The thing I want to keep is the Fourier transform method, because that was by far the fastest method. Okay. Taco crumbles under pressure. Grilled cheese is buttered so can easily slip away. You know, that's valid, I guess. Taco skill issue. Oh yeah. Thank you, collar cone. Grilled cheese, but only in a fair fight. If it's a prison rules, I take the taco. There's never just one taco. That's true. A single taco feels bad. I never had a food fight, no. That sounds kind of gross. I wouldn't really want to be in a food fight. Um, so let's just off the bat, I want to solve it for like 30 time steps now instead of the 9 we were doing before. We're gonna need to modify, actually, so let's bring Omega Zero downtown. Okay, so let's look at part 1. So part 1 is, what was it? 2 oppositely charged Gaussian vortices next to each other. Okay. If I ever, no, I already read that. I feel grilled cheese would just win because they would just be the leftover that no one wants to eat. You don't like grilled cheese? I think I need to close my shades. 1 second. The lighting on me looks weird because of the light from that direction. This is our first sunny day. It's not even completely sunny. That's like the first time it became sunny, but that's our first sunny day here in like a week. Actually, yeah, exactly a week. But I'm not complaining because I like rain. Grilled cheese overrated is what people in the what people in the northern hemisphere overvalue. That's the source of all our weaknesses, us northerners. Our affinity for grilled cheese. That's what'll be our downfall one day. Well, you know, if people claim that hot dogs are sandwiches, I think by the same logic, tacos could be sandwiches. If you feel that hot dogs are sandwiches. Sometimes I was eating like a true PhD student, pasta and tofu. Should do a food tier list for grad students. I've been eating like a grad student. It's been really bothering me, but I haven't been cooking anything like particularly complicated since I started grad school. Americans are getting more and more obese. Lol. I think that's. I mean, we certainly are, but that's not just us. Um, what's it? What's the reaction? As ACAIG, as cool as it gets. Okay, cool. Um, one, or I guess two opposite charge. Sure. Don't you have to lose on average 400 pounds per person in the new program? What? If most people lost 400 pounds, they wouldn't exist anymore. Not every American is a blimp, guys. Just some of us. Somehow she weighs 20 years ago. Dr. Oz wants each American. Oh, well, that's Dr. Oz. I would believe that. Um, I'm gonna Google that off, like not showing it on stream. Dr. Oz. I'm just gonna Google Dr. Oz 400 pounds. Let's see what comes up. I see people posting on Twitter about that. Oh, I did hear about this. Okay, yeah, I remember that. Syntax error. Hello. I went to lecture for the first time in like 2 weeks. Turns out they're behind me. Nice. Become negative mass. I'll become anti-Dawn. Dawn made of antimatter. Okay, so how do we want to do this? We need, I guess, for our initial omega, we need to do the sum of two Gaussian bumps. I guess difference. One will be centered. Well, wait, how does this work? Why is this centered already? Like, why is this already at 30/30? Shouldn't it be at a maximum at 0/0? From Dawn factorial to Dawn gamma? Because I'm now analytic. I believe it might be due to them expecting people to be employed. Little do they know. Oh, that's a big assumption. True. Simulation of the worm dancing. Yeah. On the first day of this class, we were shown a simulation. Like, you can actually simulate a worm and, like, the actual, like, neurons that make the worm make its, like, decisions for where to go and what to do. You can simulate that. So simulation of, like, a bunch of worms with like food in the middle, and they're like wiggling towards it. Why does this function not have a maximum at 0/0? Because isn't that where it should have a maximum? Because right now it has a maximum at 30 something. You can. Oh yeah, because I have that thing. If I wasn't too lazy to make stuff like this, I would want to make a chat window up there that renders LaTeX. So that way, like, even though it wouldn't look right in your chat, you could like look up there and the LaTeX would actually like get rendered. There's a couple of things for the stream that I would like to make, and I just kind of haven't. What is stab G? No, I said I want to make it, not that I have made it. I've even started. I don't know what it would take. Okay, you know what? I'm done thinking about this. Let's just mess with this. What? When I press up arrow, I want to go up. Okay, then let's make these things something symmetric. Okay, this is my guess for how it should look. Stab equals stabilizer. Who is left with more questions than it answered? Thank you. Let's see. Whoa! Cool. Let's make them closer together. Let's say -3 +3. Oh, Fizzbuzz, of course you're here for this. Whoa! Why are they doing that? Get even closer. Oh, the Milky Way and Andromeda can collide? I think that's very different physics. Wait, okay, so what do I put them... Okay, no. What do I put them on opposite sides of each other? Because I feel like they're like... They're kind of like... It almost looks like they're repelling each other. Or something. Oh, no, I guess... What the hell? Interesting. What if I had changed their scaling? I made them... Did that make them smaller? I meant to make them bigger. I don't know if function transformations work anymore. We're just gonna guess and check. That does make them bigger. This is really low resolution now, I feel like. Can we make it... Oh wait, we do have to go by powers of 2. Let's go to the next power of 2. You know, why not? Let's actually just express it as powers of 2. 2 to the 7. That's 128. Ooh, it's taking a little longer. Here we go, not that long. think we need to simulate it for longer. I want to make them collide. Huh. Okay, let's go back down to 6. Okay, let's actually... Maybe we should focus. Two oppositely charged Gaussian vortices next to each other. Let's just get that, so it's out of the way. So let's separate them back a bit. I want to see how our galaxy gets destroyed. Yeah, let me just simulate the heat death of the universe really quick. Well, something will probably destroy our galaxy before that happens, right? I don't know. Ooh, the resolution's looking a little rough. Again. Should I make them bigger? Cool to see an animation where our sun explodes and disintegrates our entire system. As it won't disintegrate the entire system. I think only out to like Mars or something. You know, if you're on Neptune, you're just gonna have a good show. Let's go up to 2 to the 7. If all this can be done in Julia, I don't even know the first thing about Julia. Well, it has something to do with it. It's like one of those languages that are geared towards math, right? But should I make the domain bigger? I'm kind of afraid of doing that. But I don't like that they're going off the top. I could start them lower down. That's a thing I could do. Let's say like -6. That I might need to do +6. But why figure it out when I can just guess and check? God, that looks so trippy. Gone to concerts, got drunk, woke up late. I've not gone to concerts the night before class, so no. I've only gotten drunk and high at concerts, though. I just don't have anything to do the next day, so it doesn't matter. Should I have got? Maybe I haven't gotten high, to be honest. Only in Daisy. It's okay, you know, it is kind of annoying me. Oops. The y-axis is really annoying. Like, why does it do that? Does that have anything to do with the reshape? This part of the homework is due on Monday. Should I care? I shouldn't care about the y-axis, right? I need to put a title here, though. That might be a little bit of a long title. Think we'll make combo pasta plus tofu's night? Hell yeah. Work tomorrow, it's done. Another homework due Thursday, it's not done. That's good. Oh, Amber Alert. What was I about to say? I was gonna say something, but now I don't remember what. Oh yeah, yeah. I've got two final projects that are gonna be due in like a few weeks. One of them's a group project, which I really hate. Oops. Underscore. I've got a regular homework due next week. That'll be the last one for one of my classes. Another regular. Actually, I've got three. I got a regular homework for each of my three classes. Ugh. Am I gonna get dinged if I don't label my axes? I feel like I might. But, oh no no no. I think there's very little consistency with when libraries use underscores or not. All right, not bad. That'd be our answer for the first one. Um, The second one, two same charged vortices. What? Bruh. I'm gonna try and keep the order. So like the first thing commented will be the like all the corresponding stuff, and the second thing commented will be all that stuff. So I just changed that to be a plus. Now what happens? No. It's kind of I have a single final exam for one for one of my classes, and that's gonna be the only exam I'll have taken all quarter. One of my classes has quizzes that are like a weekly thing that are small, and you get multiple chances at. That's like the closest thing. That's not the right one. Whoa! This doesn't look right, but that looks sick. I think they're combining into one? Is that what happened? Oh, that looks so cool, though. Okay. I think maybe let's not offset them in Y, because it doesn't look like they're traveling now. Let's split them up a bit. This semester you have 7 exams in total? That's a lot of exams. How many classes are you in? 3? Okay. Dang, so that's like a final in all of them, a midterm for 2 of them, and then 2 midterms for the last one or something? What the hell? What? Oh, this looks so cool. Oh my god, I love this. Homework every week, 5 exercises. That's a pretty heavy load. Maybe let's make them a little smaller. I want to clearly see them both separately at the start. I'm close to solving Navi or Stokes. I am. I want my $1 million. 2 worms are showing each other love. Careless Whisper. Yeah. This might be another saxophone song. Maybe not. But we did just have the saxophone song playing. One of them. The periodic I think I want them to be even smaller. Because I don't like that they're running off the side of the screen. Because I think it's making it less clear what's happening. Careless Whisper wouldn't. You know, I guess you're right. Okay, here we go. This is more like it. Ooh, ooh. Oh, now they're a little bit too far apart. This looks cool too, though. God, these all look so cool. Maybe let's bring them a little. Just bring them a smidge closer. Oh, this is it. This is it. This is it. This is it. Oh, this is it. God, that's so cool. I fucking love this. Okay. That's a keeper. Keeper, hardly know her. With 10 vortices, that's gonna be the fun part, is finding out if it does. Okay, so we did part 2. Part 3 is to make 2 oppositely charged vortices collide. So we got to keep playing with the initial conditions. Okay, so how does this one look again? Yeah. All right. Good luck with your exam. Godspeed. So do I just make them really close, I guess? What is that going to do for us? No, I don't really watch South Park. Like I've seen some episodes, but honestly, I haven't, like, some of them are funny, but a lot of them are just kind of okay to me. No? There's no collision there. Um Hey Papadoria, how's it going? Oh wait, that's the opposite of what I wanted to do. Ooh, they kind of seem like they're maybe gonna collide eventually. They kind of bounce apart from each other, then they come back in. Huh. This is stupid. Are they just gonna cancel each other out if I do this? Yeah, they are. Let's do like plus 0.5. Started some quiet, minimal, complex analysis on my own. Nice. Explain in particular, the Lagrange inversion formula. That sounds familiar. Let me just see where the simulation goes, and then I'll Google it. Nah, it's not really doing what I want it. feel like that's something that I've Googled before. Fun. Hey, is it a parabola? This isn't. No. But that that is a thing in math. Actually, this kind of in a way is a parabola hidden inside of this. I hope you're doing well, Fun. So yeah, okay, we do require analyticity. Oh, is this just a rearrangement? Huh. Well, maybe no, it's not just a rearrangement. The gamma function to get an inverse factorial. Ooh, cool. Yeah, I'm doing good, Fun. I just went to Google this thing, but the mission of the day is to make these cool visualizations. So that's what I've been working on. This one is my favorite one so far, I think. But this is a simulation of a vortex, or in this case, two vortices next to each other. And I just I love this shit. Um, um, I've definitely seen this before. I never had to use it. I never learned about it as part of a class. I don't know how popular this thing is to use, like in terms of how niche it is. I doubt you need. I doubt it's that helpful with theorem. It probably comes up somewhere though. I'm using combinatorics apparently. For Lambert W. Oh, that's kind of cool. Yeah, Lambert W is a good idea. Binary trees. Hipster equations. You know, yeah, I guess this is sort of a hipster equation. Like, it's kind of vague. You probably haven't heard of it, but I'm really into them. Um, so you can get a closed form for B sub n. That's kind of wild. I didn't know that this is a thing that you even did with binary trees. Ooh, for asymptotic approximation of integrals. Really? So yeah, it seems like this is actually pretty helpful. I'm learning about this next quarter, so maybe I'm actually gonna run into it at some point. Oh hey, here's someone asking that same question. Oh, you can explicitly solve a fifth degree equation. Gasp. Huh. You can solve a quintic. A any quintic with it, apparently. That's pretty cool. I wonder if it works for higher degree polynomials. Discovered by Lambert. Discovered by Einstein when he was 14? Oh my god. Frickin' Einstein. It's like that dude is really smart. Yeah. Greatest disappointment. Oh wait, what happened today was when I was teaching my brother about the gamma function, he asked if there was an analog of factorials with addition instead of multiplication. Then I realized with greatest disappointment that a sum factorial is just an arithmetic progression. Yeah, it is. Oh wait, Eisenstein? Oh, it is Eisenstein. Okay, that's still really Eisenstein is still like really smart, right? And it's incredible to figure out at 14. I was wondering, like, Einstein's a little young to be 14 and or to revert into something 1844. Eisenstein, he's a poser who's easy to get mixed up with Einstein. No, I don't remember. I don't think this is him. This looks more like it. What is that? 29 years? Yeah, he died at 29. Oh, good. I'm turning 29 next year, so. Number theory and analysis. Oh, he had health problems. Dang. Isaiah 14 is a little young. No, I mean, like, yeah. I didn't phrase that well, but I remember, like, Einstein's, like, his big paper on special relativity was in, like, 1901 or something. So that's a pretty big gap from 1844. Okay, Eisenstein is also really smart, though. He accomplished a lot of stuff in his 29 years here. Yeah, his name sounds familiar. I definitely heard his name in some context somewhere. I think he could maybe use some better advice on like bow ties, but other than that, so yeah, I mean the thread seems pretty good for what you're asking about. That's a cool little like rabbit hole that brought us down though. Um, all right, how do we make these dudes collide? I assume swapping their positions isn't going to do much. I don't think that did much the last time, but let's just try that. Oh, they're going the other way. Oh yeah, that makes sense. Okay, let's put them back. Uh, I'm just kind of playing with numbers. I don't really know how to make this. If I put them far apart, would that do anything? I assume that it's better to put them close together, but well, maybe farther apart would do something helpful. Collide. Collide. You know you want to. Damn it. Okay, let's go back to 20. Let's do maybe 5 and 5. Yeah, that's kind of like the way that they structured this homework. Um, we start with initial vorticity and we get everything we need from that. Woo. Huh. This is a little like touchy though. Like it seems kind of hard to just set this up. Like it doesn't have to be a Gaussian bump either necessarily, I don't think. Oh, well, they do say with Gaussian bumps. Hmm. Like just for funsies, let's just do X times a Gaussian bump. Oh wait, that doesn't make any sense. X vowels. Like, does that do anything special? It's taking a lot longer to run, I think. The computers, I can hear complaining. Why is this making it so much harder? There we go. Woo! That's a... What the hell? I have no clue why it came out like this. We might hang on to this one just because it's funny. That's not what we want though. Yeah, it's basically what this is, Papadoria. I wrote like this code, and now they're making us like define initial conditions to make certain things happen. So I'm supposed to make two oppositely charged vortices collide, which they seem to want to do the opposite. Um, what did this one look like again? I already forgot. I'm wondering if I should just increase the amount of time that I simulate it for. Excuse me. Oh, it's not done yet. Sorry. I was rushing you. Okay, so let's get rid of the y offset. And then let's increase the amount of time. Let's go up to 90. No! Touch each other. Huh. Dude, the music right now actually kind of goes well with this visualization. Um, I don't know. Let's just try bringing them closer together again. Come on. You can do it. There we go. They push each other away. How is this possible? So that's what it seems like what's happening. Hmm. What if I do one, like, what if I make them in opposite corners? Like, across from each other diagonally? I don't know why that would change anything, but let's just do random shit until it works. This maxes out my CPU whenever I run these simulations, so I don't think it's going to impact the stream. It shouldn't. Oh, okay. Huh. I don't know. I do not know. Ooh, well, okay. What could be fun? What if one is twice as strong as the other one? Ooh. This reminds me of like mixing batter. These things, like, I don't think. I wonder if they meant same charged vortices. Because, like, I really. They seem like they repel each other when they're oppositely charged. God, I love this one. Okay, maybe we'll just put a pin in this one for now, because I'm a little confused by how this is possible. But we can do the fourth one, which is a random assortment of vortices. Just like how I like my donuts. Random assortment. Lucas, for some odd reason, I am doing I'm better at doing harder math questions than doing easier ones. um, honestly, I feel that way sometimes too with certain types of questions. Or like, I can sometimes be able to prove something, but then actually using that thing to do a calculation, I get completely stuck. Okay, how should we do random assortment? We might need a bigger domain. Oh, Olympiad. Well, those are just hard questions. Oh, or you mean like you can do like this type of question, but not first round isn't hard, but I can't do it. Oh, I mean, where can I find like an actual okay vegetable? Oh, okay, here. Okay, BWO is the harder one. Okay, I clicked on JWO. I did. Oh, skirt. BWO is the hard one. Okay, okay, here we go. Skirtle. I'm simulating how I imagine uh like your house when all these storms happen. Oops. What? No, zoom out. You know? There's just all this like crazy stuff happening. It is fun. They seem to add in a volcano explosion, and it's basically like where you live. Um, is there like a there should be a way to translate this page, right? Somewhere in this browser. I'm looking. It would be cool to add a volcano. I don't know how that would work though. Um, oh my god. Firefox translate page. Oh. If it doesn't show up automatically, that's not a thing. I can always just go to Google Translate. Question 3. I can't translate any of this, I don't think. Oh, oh hey, translate selection to English. Oh, you can't see this. From Dutch to English. Which figure is congruent with the side-by-side figure? Which of these figures is congruent with this figure? What do they mean by congruent? Like, is it just like a rotation, or like it's B, right? It's just a rotation? Is that right? Wait. No, this triangle is on the wrong side. I think, okay, C. That's what I guess, because C is just a rotation. That's a weird question. Wait. Why not E? No, E is wrong. Yeah, no. I don't know what they I don't know. This is a weird question. Like I assume they just mean like E is the same, but like this line looks wrong. That's what I didn't like about E. Okay, fine. What's number two? If you rotate the line also I feel like that's a definition thing. I don't know. Like you could like make it either way. Um the 10 cards in the figure are for luck on table. He divides the cards into 5 pairs with the same sum. With which card does the card with which card does the card form with the number 22 a couple? Oh god. Let me just get this like separately into Google Translate window so you guys can all see it too. Pasta and tofu combo? So like pasta with McNuggets in it? Hell yeah. That sounds like a fantastic combination. Wait, okay. 5 pairs with the same sum. So these aren't already paired, are they? No, they look paired. Kind of. No. What the hell, dude? Okay. They aren't already paired. So presumably 46, the highest one, should probably go with the lowest one. That's probably the most reasonable thing to test first. 58. Wait, do you know Dutch Skirtle? Or did you use Google Translate? 38 should go with the next highest, lowest, 18. That's not right though. That's 56, not 58. That's odd. How are you supposed to do this quickly? It's just a lot of work. Okay, what if 12 can't go with 38? So I said 12 can't go with 46, 12 can't go with 38. So 12 must go with 28? Does it? 46. Oh, wait. Never mind. Oh, it's the thing. Am I misunderstanding? No. Wait. I don't know, dude. I'm so confused. It can be any 10 cards. I was thinking like the top row has to go with the bottom row. Like you can't do 32 and 48, but I think you can actually. So, okay, Luke's saying highest goes with the lowest. That's what I thought. Okay. 48 then would go with 12, which is 60. 46 would go with 14, which is okay. So okay. That's what was confusing me then. I thought the organization with rows like meant something, but it doesn't. Okay, so we're making so 22 goes with 38. Okay, now that I know what the question is, that's not that bad. All right, we'll look at this one too, and then I'm gonna go back to my other thing, I think, but it's kind of interesting to see these. Ooh, some more geometric ones. What the hell is happening here? Oh my god. Okay, these look kind of crazy. Try 21? Okay. Ooh. A semicircle with area A is drawn on the hypotenuse of a right triangle. Okay. A semicircle with area B is drawn on one side of the rectangle. Sure. A quarter circle with area C is drawn on the other side of the rectangle. Then C equals... Oh, this is kind of a funny problem. I need to do some writing here, which we can do. So, what we anticipate seldom occurs. What we least expected generally happens. It's not a bad fortune. It's not my favorite, though. So we know that a is equal to, say, 1/2 pi small a squared. It's true, but also not true. Yeah, exactly. And I guess I'm saying small a. Ooh, I guess small a is this length. And so small b is going to be that length. And small c is going to be that length. So we know 2a squared equals 2b squared, or not 2b squared, plus 2c squared. And the 2's are going to all cancel. So we can just say a squared minus b squared equals c squared. I'm glad you heard that. And then I feel like this is probably not the intended way of doing it, but like we can just multiply. Ooh. Okay. If I multiply this equation through by 1/2 pi, we recover a and b, but this is twice of c. So I think the answer is a minus b over 2. Is that a? It's a, right? I don't think we need a square root. Wrong? Bruh. Oh, ooh, it's because of the way I define C. C is a quarter. Ah, that's so annoying. How do I fix that? Is A truly A, or is it just an illusion that is bound to disappear? The latter. It's just something that we humans invented. It doesn't actually exist, though. Bruh. And there's that gold hat has it emote. It's great, though. You got D. Really? I feel like there shouldn't be a square root. Okay. I guess this needs to be 4C. No. Ah, it's this equivalence that's wrong. I'm gonna say that c squared is the same thing as 1/2. Famished on the YouTube side. Hello, hello. Same thing as 2 times c over 2 squared. Actually, I want to bring the over 2 out. So that's going to be 1/8 pi times 2c squared. Hey, I am test played. This is in Dutch. It's a question from Lucas we we're just kind of messing around with. The translation is here. Welcome in. I thought I did this right, but I got tricked. This is a tricky one. You ain't... Yeah, you're not Mistral there. They're all tricky. I can believe that. I think Olympiad problems are all a bunch of like tricks and you just have to like learn them. Okay, so this we can say is C. But that's not... Oh, that's still wrong. Because I'm going to get a 4. And that's definitely wrong. I'm going to bet the answer is C. But I can't get it right now. I don't know how to get it. Oh, when you're out and about right now? It is C? Yeah. I'm not doing this manipulation right, but I know it should be C because I was off by a factor of 2 that was going to get squared. So I knew it should be 4 times what I got. I don't know how to show this work in the right way. Yeah, I don't know how to do it the right way. 24, 25? Looks like a Sudoku. Where's Fembox? Teacher Frank has his students. It's 24? Okay. Filled out a multiplication table. He already filled out 4 products. What is the sum of the 81 products? Oh. Really? Huh. How would you do that? It's like you gotta... There's Fembox. I knew you were here. 2025. How do you... It's 45 squared? I'm trying to work that out. Hey Raven. Uh the main thing of the stream is I'm writing some code to simulate uh like different vortexes. Like I'm making cool visualizations like this. We're taking a little break from that to look at some questions from Lucas though. I was looking at these I think like high school Olympiad questions that are in Dutch. You like those? Yeah, I think they're really cool too. Table filled in is filled with the entries of 1 plus 2 plus 3. Oh, that's so clever. That's not, that's the type of trick that I would never think about. So what Felix is saying, I think, is that if you do 1 plus 2 plus 3, oh yeah, that's right. 7, 8, 9 squared, and instead of writing squared, I'm gonna actually do that. The act of multiplying this out is the exact same thing as adding up the sum of the table. It's like you do 1 times 1 plus 1 times 2 plus 1 times 3. Do you need to multiply it by 2 though? Maybe that's already accounted for. No. Okay. Now, question. Let me just bring in a screenshot of the question. Is Fenbox's idea, is that only getting like half of the table like that? No? Hmm. Oh, okay. Or 1 times 1, 1 times 2. Oh, no. Okay, no, it's right. Because like looking at like we get like this 1 times 2 from that 1 times 2, but then we can get the other one when the 2 gets multiplied by the 1. So yeah, I think we are covered. Ooh, Raven. Is that like a Gauss's something? That gets the right answer, or does it? No, it doesn't. Yes? If you square it, that's the right answer. Yeah, it seems like a test play. Hmm. All right. Maybe we'll do one more before we go back to the simulations. Try one. Okay. It's a lot of text. Um, Remarkably, I guess we can actually put the translation on here. Okay, there we go. They have to be between those numbers, BTW. Oh, okay. Ahmed, Bert, Chloe, Danira, Eva are sitting at a round table. Everyone has a stack of coins in front of them. They pass a number of coins in succession as follows. Ahmed takes half from his stack, places it on Bert's stack. Bert takes a third from his stack, places it on Chloe's stack. In succession. So I think Bert receives the 1/2 from Ahmad and then takes a third. That's how I'm interpreting this. Chloe takes a quarter, places it on Danira, a fifth, a six. Remarkably, everyone ends up with the same number of coins as they did at the beginning. Everyone had at least one coin at the start. There are no more than 20 coins in total. How many coins are there in all the stacks together? I mean, this is multiple choice. Is it best to just guess and, or like, not actually check, but like check the answers? Least common multiple of the denominators. Ooh, that's a good call. Something to like think about. I think it's gonna probably be 60 though, right? I don't think there's anything lower. Yeah, I think 60. Would you do 60 divided by like 5 people is 12? That's a complete guess. Like that's just gut intuition. I can't really justify it. But let's try 12 and just see what happens. Yeah, that's true, Raven. Oh, it's convenient of them. A, B, C, D, E for the names. A, B, C, D, E. Okay, so let's pretend that we start with 12. Wait, so... Oh, wait, 20 coins in total. Wait, they don't have... Do they all have the same... Do they have the same number of coins? I don't see them saying that. Yeah, it's possible there's a translation issue. They end with the same number of coins as they did at the beginning. They don't necessarily have equal coins, right? Ooh. Yeah, that makes it so much harder. No more than 20 coins in total. So if they all split, if they had 20 coins in total and they split them up equally, that'd be 4 each. Okay, what if Ahmed has 2. Ahmed will give 1 to Bert. I assume like we do need to do multiple, like that they need to go in evenly. So Bert needs a multiple of 3. So if Bert starts with 2, he'll receive 1 to make 3 and then give 1 away. If Chloe has 3, she'll then have 4 and give away 1. Am I just doing it right here? 4. We'll get 5, give 1 away. 6, give 1 away. Oh. 2, 4, 7, 11, 17, 16? D? That's what a weird question. There's a lot more to this that you could say, I think. But I was just able to brute force it. Interesting. Am I winning the streamer award in math? Probably not. There probably isn't one either. Okay, looks like we agree. Nice. The streamer awards, like, are they just a popularity contest? Like, I saw streamers asking for votes on that, and I don't know. I don't know those things even work, to be honest. All right, that I'm sure there's a way to like you could really like analyze that question. I don't know what it will be, but this is long. Holy crap. 30 questions. How long do you get to do this? $180. 3 hours? Okay. That's not unreasonable. What is that? Oh, that's only 5 minutes per question though, isn't it? That's actually, ooh, God. That's pretty rough. Like, that's doable, but that's rough. You gotta really prepare. Yeah, I can see that, Lucas. That's pretty rough. Pretty varied questions though. It's the URL. This was like the main website, and the one we were just looking at was this one here in VWO. Dare de Ronde? I'm just gonna control F. Oh, never mind. Is that on a different page? What about Ronde? Different page? Oh, this is like the entry round. Okay. Maybe an archive? Tweeta Ronde? I'm sure I'm saying this terribly. Would Durde be 2? Under 20 minutes for 30 questions still? Bruh. This one is a funny figure. $21 is odd. Let's see. $20? Oh, no worries. Got a triangle. Small color triangle with area 1 in a white quadrilateral. What is the area of the white quadrilateral? Isn't this just a whole bunch of like law of, well, Ooh. Let's try it. Wow, Fembox is on it. Fembox, you need to go to the Netherlands and compete, apparently. You messed up? Oh, okay. That makes me feel better. So we know the small color triangle has area 1. Oh, there should be a theorem. Well, maybe there isn't a theorem because this isn't parallel to that. Otherwise, we could probably have a theorem. Herons? Oh, that's a common one for competitions, and I don't know it. That's a good call, though. Yeah, that's a great call. We don't know the third side, right, though? Yeah. Um, well, we can figure out this length here, though. That's possible. With herons, right? Well, we're gonna have... yeah. I guess we can always do that, because we're probably gonna need it. So, root semi-perimeter. That's half perimeter, right? Yeah. That's the last round? Oh, okay. Well, let's do this one, and then we'll look at that. I guess I'm gonna call this C, because why not? Yeah, the area of the small one is given. This is... I don't want to solve this. This is terrible. Well, it's not that terrible, but it's still kind of annoying. We'd solve this equation for C. Yeah, it's Heron's formula. But even then, this isn't the entire answer to the problem. This is just a piece of the problem. How do we solve this in a way that isn't really messed up? The weird formula sign? Yeah, I was wondering about law of sines. This kind of feels like it's not it, because I don't know what the hell you do with this, actually. I don't want to solve a quartic. This is not it. Okay, if we call this angle theta, we can probably work some magic then with law of sines. Well, can we? That's like the one angle actually, well, uh, with signs. Like, are you talking about like sine A over A equals sine B over B? Or something like that? Or maybe law of cosines then. There is c squared equals a squared plus b squared minus 2ab cosine theta. Or like angle c. Specific. Oh. Yeah, I don't know then. Then it gets easy. That makes sense. All right. Let's look at the finale one. I do want to get back to my simulations at some point here, but let's see what the finale looks like. How many problems? Only 4. Ooh, that's scary. What looks fun? I'm kind of leaning towards 2. I don't know why though. The others just look way scarier. Well, 4 I don't know, because it's all words. Um, okay. So if we want f of 3, the obvious thing to try first is select k equal 3. 3, oops, plus 2f minus 2 equals 9. So we want to get rid of the negative 2. What does k equal negative 2 give us? Can I just subtract these 2 equations? I guess I need to multiply... Okay. Take that, multiply it by 2, and subtract. That's what I'm doing. So we get minus 3 f of 3 equals 1. Yeah. So negative a third. prove f of k is not an integer for any k and z. That seems a lot harder. Well, can we repeat the procedure with the generic variable? Just like k equals a. And then compare it with k equal 1 minus a. This song sounds so familiar. Comfort Chain by Instupendo? I have no clue. Never mind. Hey, Aikido. On Falconer scan equation? I haven't heard of that one, but sounds good. Thank you for the work. High school BTW? Yeah. These are pretty crazy. Okay, and then I want to do the same thing. Multiply by 2 and subtract. So we get minus 3. I keep making typos. And hopefully we can prove that this thing isn't an integer. Let's multiply it out. Yeah, sure. I'm almost done with this, and then I'll take a look. Minus 4a is 2a squared minus a squared over 3. That's not factorable. Okay, so I guess the problem now is prove this thing is not divisible by 3. And then you're done. How would you do that? A minus 2 cubed? Over 3? Why cubed? Determinants? I'm not sure how you use determinants, but maybe you can. A minus 2 squared? That's not how this factors. It just doesn't factor. Well, what does the quadratic formula tell us? B squared minus 4ac. Ooh, wait, does it? Am I bad? 2 root 2 over 2. Okay. Actually, no, this seems helpful because this is definitely not an integer, right? Yeah, it just doesn't easily factor. Also, hey, Dr. L. 2 plus root 2. A plus, no. A minus, 2 minus root 2. Over 3. That's not an integer. I would bet money on that. Considered not an integer if I was in high school. There you go. Let's see what Aikido posted. Fiona's working on the well-posedness. Okay. Let's see. We'll at least read the other one Lucas called out too. I was kind of messing with it. I'm kind of surprised I was able to solve that one because I'm normally really bad at that type of question. Ooh, okay, so it's like a flow of a fluid with a wedge there. That's awesome. Yeah, thanks for sharing. This is a cool thing. The triangle might be 1/2 AP sine theta for area. Really? I don't know. I don't know if I've heard of that one. Oh wait. Oh, I have. Yeah. Okay. That's just that makes sense. That does make the problem a lot easier, I think. Yeah. So the other one Lucas said was number 4. "26 students in 5th grade have a fixed seat in the classroom with 26 chairs. First, having my sit down in a random chair. Oh, God. This feels like the birthday problem. I bet this one is easier if you do the inverse. It's half? It's not multiple choice. You've seen it before? How? The prisoner's problem? Oh yeah, it reminds me of that one too, yeah. Prove it by induction on the number of seats on in the room. What? Induction? Okay, well, for induction, we need to figure out a rule that we claim is true. What would the rule be? Can your students out from the classroom multiple times? Yeah. It's all by giving Adam a detention. The EMF opposes the rate of change of the magnetic flux. That's my preferred definition for induction. Go to. Let me turn on my background lights. Permutation combination? Maybe. So we probably need to start with a simpler thing. Like, if there's just 2 students, it's a 50-50 shot. If there's just 3 students, we should probably... Yeah, let's figure out the 3 students case. 1, 2, 3. Adam has a 1/3 chance to sit in the proper chair. And if that happens... Okay, yeah, so maybe we should just say the scenarios where Zoe gets her seat. Adam chooses proper, I guess, his seat just by chance. That's 1/3. Adam chooses wrong, but student 2 like doesn't take Zoe's seat. This is a lot of rating. So that's a 2/3 chance times... You're going to bed? All right, Lucas. Oh wait, but Adam can't take... Oh god, so it's 1/3. Thanks for sharing those problems, Lucas. Sleep well. So it's 1/3 times 1/2. Okay. And so a 1/3 plus a 6 is 1/2. I expect it to be 1/2 for every number of students, based on what Femlock said. And so I think I can maybe piece together the pattern now. It's going to be, if we have n students, one over 26 factorial. I don't think it's that. It's going to be 1 over n plus 1 over n times 1 over n minus 1. Zach, hello. Hope you're doing well. How's lurking on you? But I had a pretty busy morning / afternoon. Lucas has managed to have a really good distraction for me. But we've been making some simulations. I think this one's my favorite one so far. They blend together. But yeah, we also got yeah. We've got this one too with spinning in different directions. Yeah. So this is what I was doing until Lucas Sorry, putting these cool problems there. Distractions. What? This is Twitch. I know, Zach. This is a place for focus. This one I'm about to click on is crazy. I don't think it really means anything, or I think something went wrong, but it looks cool. So, yeah, it'd be cool to make some like starting soon screen or BRB screen with these visualizations at some point. But yeah, so I got stuck. I'm supposed to be able to make two vortices with opposite charges collide, but they've kind of been repelling each other, and so I've been struggling to get the right initial conditions to make them collide. This one's a cool one too, but it doesn't. I think this yellow one with the positive charge is like, it's twice as strong as the negative one, so it just completely overwhelms it. But yeah, for reversion, like if they spin different ways, they don't seem to want to collide, and so I've been kind of struggling to make them collide. That was the mission that I was on before I got distracted. Be cool to figure out this problem here. What's the end game for this summation? Ooh, wait, is that one? I think it's n minus one. So wait, Adam. Ooh, yeah, wait. Adam can choose. No, wait. This first scenario is Adam choosing the right, his own seat, and there's only one. This scenario is Adam choosing any seat besides his own and besides Zoe's. So it should be n minus 2, actually. And then the next... Well, this might even need more terms. I don't think I'm doing this right. The next person has n minus 1 seats, good seats to choose from. Wait, n minus 3, right? There we go. That makes more sense, I think. Over n minus 1. Maybe this is the progression? But why are these two coefficients, or why are these two numerators the same? I don't know. I'm getting stuck on trying to do this for an arbitrary number of students. There is a way to do this. I'm just like not thinking about it right. Yeah, I don't know. I want to just drop it and go back to my No, I think Fenlux is right that the answer is just 1/2. I just can't figure out a justification. Triangle problem. They put the formula in chat. That's the good one to use, which is area equals 1/2 AB sine theta. This, I believe that you could use that to solve the problem. But the glowing sun, thank you for the follow. I just noticed on the crazy triangle problem, the little triangle is 9/11, and the big triangle is 9 plus 92, or 8 plus 88, 101/99. What the hell? How do you notice that? It's a conspiracy. There's probably a reason why it looks like that. I couldn't tell you what, but it feels like that's not a coincidence with the construction of the problem that there should be a relationship like that. Theta equals 30. That seems reasonable. 1/2 times 9 times 11 times sine theta. Really? Wolfram's alpha, save me? It's just not. We don't. Hmm. This is 99/2. Okay, never mind. Maybe that's not. I don't get 30 degrees at least. um. Hoo-hoo. Holy crap, it's been a minute. How have you been? I hope life is going well for you. Still enjoying those corgis. Love to see it. Um 2/99. Get rid of Heron's formula. That was no good. And then if we use the same formula on the big triangle, 1/2, 101, 99, sine, arc sine, 2/99. Oh, haha. 101? Is the area 100? I think it's 100. I'm doing good too. I'm in grad school now. I'm working on a master's in applied math. So I moved. I'm in Washington State now instead of California. So yeah, big change, but it's going well. The problem is a lot easier once you realize to use that formula. Okay, maybe we'll go back to pretty visualizations now. But yeah, and so just today we've been simulating like hurricanes, basically. So we're making cool looking things like this. I coded this, which is like two different like hurricanes that start out next to each other and then they kind of combine into one. I'm 28. I'm definitely one of the older students among like my like I guess like classmates. Thank you, Aikido. So for part 4, we need to do a bunch of different vortices. This could get really chaotic. I guess that's the point. Let's go for like 10 vortices. Scaling max, let's say up to 20. I'm just defining some parameters here, and then we're gonna randomly generate these things. We're gonna need. I need to remember how to do randomness with NumPy. We'll figure it out though. Scaling max, strength max. Maybe we'll say 3. I feel like we should keep that low. Do we want anything else? I think that's good. We're doing randomness in this homework. Yeah, Markov chains. That has randomness. NumPy. There we go. That's what we want. Dot random? Dot default RNG. Okay, so for I in range num vortices. Ooh, yeah, okay, so omega 0. It's going to start out as zeros. How big? I guess it's x vals dot size, y vals dot size. Ah! I keep knocking my pen or my stylus over. Okay, for I in range num vortices, omega 0 plus equal. Oh wait, no, we need to get some numbers first. X scale equals RNG dot uniform. And how does uniform work again? Okay. So for x, the scaling for x, we want positive numbers. Let's say we don't want it to be tiny either. Say like 0.1. Up to scaling max. Well, I guess we actually want 2 of these. One for x, one for y. The strength, oh no, not strength can be positive or negative. So we want minus strength max math max positive strength max, and just one is fine. Omega 0 plus equal strength times we need an offset too. Let's say 6. I don't know. G dot uniform minus offset max plus offset max, and we want 2. Okay. Minus offset 0 divided by scale 0 y vowels minus offset 1 over scale 1. All right, this is gonna be wild. Let's see. Oh wait, no, we did already. Okay, good. Let's see what we. No, 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 no. Print. I want to see what random values I get so I can recreate it if I want. It's gonna bug me. Okay. I have 2 different scales. That's what I'm missing. Actually, I don't need to do it one by one. Just for the entire array. Strength. Strength. Okay. Bam. Let's see what happens. Nothing. That's what happens. Why do you do this? At least no bugs. True. Thank God there's no bugs here. That'd be terrible. Why are you doing this to me, program? $128, $128. Really? It's that small? Actually, duh, it's that small. Why are you 16,000? That shouldn't be happening. Is the plus equal thing not good? Working on simulating the equation that you showed me earlier. Gonna get back on paper. See, couldn't I'm back on paper to change my mind. Nice. It's tough. Oh, I know what's... Haha, okay, okay. I should just do n by n. There's your problem. I feel like my domain is going to be way too small for 10 vortices, but let's see what happens. It's still simulating. It's working. Come on. Drum roll. I don't know if my mic was picking that up. Uh, it's not a very like good reason because it's not really addressing the issue. The only reason I do this is because I showed this on stream, and I just don't want to accidentally read some file on my computer and like dox myself. So I just wanted to put it in any like VM to kind of make it harder to do that. I think I still could accidentally do that if I did the right thing, but it's at least like a little bit harder. There's no other reason to run it on WSL that I'm aware of. Yeah, it's like not like a super realistic concern, but yeah, I set it up like years ago and I just haven't really bothered to like change it. It definitely doesn't hurt. All right, let's see what we get. Whoa. This isn't as crazy as I thought it'd be. I don't see that many of them, to be honest. I wonder if they get swallowed up by that massive one. It's a strong boy. It's probably like that one. No, probably that one. I think we maybe need to tone down the strength. Let's make it 2. And maybe make them smaller. I remember like a class I took a long time ago had us do this setup with VS Code with WSL. Ooh, and they might have had a reason. I don't remember what that reason was though. They are. I've been really loving making these. Oh yeah, Fembox. You guys had a good time because my computer is simulating right now anyway. The answer's 100. I think I just used the formula that someone pointed out in chat. 1/2 AP sine theta. You can get that like this angle here is arc sine 2/99. Then you take that angle and plug it into the same formula for the big triangle. And get the entire big triangle is 101, so you subtract out the 1. Ooh, we got a simulation. Hot off the presses. Ooh. I still don't see that many of them. I wonder if they're really just not strong. These aren't as cool as I was hoping. What is that giant? It's probably this one. Should I make maybe the offset needs to be bigger. Hmm. What is my domain? It's kind of hard to Let's make the offset bigger. Let's just see what happens. Just make it 10. All right, Aikido, thank you for hanging out. I'll see you around. Famous troll, hello, hello. Yeah, welcome in to the Twitch side. Yeah, it's so easy once you know to use the formula, and it's so difficult before that. Some physics, yeah. Like if you're like learning introductory physics, I'd be able to help you out. Well, go away. What? Who the fuck are you? Sorry, there's like a fly. I thought it was a spider. I don't know where it went, and that's a problem. Oh my god. We've got a fugitive somewhere in this room. No, it's not. Well, I mean, I don't want spiders in my room, but this isn't a spider. It's a creepy looking fly. I don't know where it went. You were in my stream? Or do you mean Gold? He could be. I hope he's not. Gold? Okay, okay. Yeah, I can help with some physics. Ooh. Like you still don't see that many of them. There's maybe they're just getting the weak ones are getting swept up. Like there's 10 vortices initially, but you only see 2 by the end. This is a simulation of like a vortex, in this case multiple of them. And so it could be like a hurricane or something like that, or just like a whirlpool in water. I've written code that like simulates it. Yeah, I think it's really fun. And so I'm setting up random scenarios with a bunch of them. And I'm trying to make it like, I'm trying to get the coolest version that I can. Let's try making them even smaller. Yeah, same. This unfortunately is pretty like advanced math. Like it's from partial differential equations, which is it's something that I kind of like barely touched on at the end of an undergrad math degree, but you don't like really start to learn about them until grad school typically, which is unfortunate because they're really cool. Ooh. Oh, dude, this was sick. Oh, dude. I love this one is like orbiting. Online college of math, you have to see if you get into FAFSA. Fair enough. Yeah, yeah. Okay, this one, we're gonna rename it. I this one's kind of cool, so I want to keep it. Okay, so let's maybe get more of them now. Let's get 15. Next year can? Okay, yeah. That makes sense. What time is it, by the way? Oh my, it's only it's only 5 in the evening. It feels like it's night. Well, it is night out, but like I thought I was gonna look at the clock and it'd be like 7. Ooh. The small ones really quickly get overwhelmed. A lot of them are negative too. Okay, no, there's a lot of positive ones too. This one might be our keeper for the actual assignment. I like that you can distinctly see them all at the start. Okay. Um so I need to come back to part 3 because that one I couldn't quite get to work. I wonder if I should, instead of having them side by side, I should have them one on top of the other. I feel like that shouldn't change anything, but what if it does? I'm saying you should do some math on your own. You mean math? Either way. Oh, no, 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 no. No 2 times. Either way, enjoy. All right, let's see what we get. Um, you started on Big Red Curl. Ooh, I still want to read that book. Don't just travel side by side. Collide. Do they need to be asymmetric? Is that it? Yeah, I would really love to read that book because I'm really bothered by not understanding the intuition of Laplace's equation and stuff like that, or just like with a PDE in general. What does it mean when you see the Laplacian or the divergence or the gradient come up? You never see the curl come up, do you? That's kind of weird. I guess because that's a vector thing. They are, yeah. We have to get 4 different scenarios. So I think I've done all of them but the third one. Um but yeah, this one's been eluding me so far. Yes, like for the first part of the homework, they had us make a simple simulation with 5 different methods. Um, and then for the part now that I'm on, you take the fastest method, which was the fast Fourier transform. Uh, and try and make these like cool scenarios. No, not as far as I know. Just Gaussian functions make convenient choices of initial conditions. So like this initial like positive and negative vortices are both like Gaussian bumps originally. Oh, it's already done. Just thinking about dinner. It's not the right one. Uh oh no. I was excited for a second. I thought they were gonna collide. Then they split off again. I don't know how to fix this. I'm just doing random stuff. Oh, look, it looks cool when it gets into the corner. Because the simulation uses the like Pac-Man rules for if you go off the edge. But when you go into a corner, you show up in all 4 of the corners, I guess. Yeah, that makes sense. Okay. Because when you hit this border, you show up on this border up here. Then you hit that border, you show up on that border over here. And that's gonna like bleed over. Um, hmm. Come on, collide already. You know you want to. Hmm. I don't know. I do not know. What if I made them small and strong? Once this one runs, I'm going to try that. Like, what if they're both strength 2? Maybe that's the key. You know what? Let's see. Let's go. Let's go wild. Let's make them 3. Buckle up, everyone. Come on. Come on. It's almost there. Here we go. Hmm. They're just traveling side by side, holding hands. Annoyingly. Uh... I think I already tried making them not have the same strength, but let's try it again. Because the definition of sanity is doing the same thing over and over again, expecting it to work, right? Ooh. 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 Kinda. We got an orbit. They're not really colliding, though. What if we make... I mean, there's no way this is gonna work, but... What if we make it one of them even stronger? I see you! 1 second. The beast has been slain. Okay. Oof. Murder is thirsty work, let me tell you. Okay. Every 8 weeks is one term. Oh dang. Yeah, that's pretty expensive. What? Phobos. Hello. I hope you're doing well. Simulation we just made, I think. Ooh, it's all yellow now. Helldog. Yeah, I recognize your name. I've got a major or like a bachelor's in applied math, and I'm working on a master's. So if you call that a math whiz, then sure. If you have a question, like feel free to let me know. Oh yeah, Phobos. I'm trying to make the two collide. The best I've been able to do is get like this orbiting thing though. Partial differential equations are what I'm learning about right now, basically. So I'm doing them with Fourier and Laplace transforms, and I'm doing numerical simulations like what you see here. So, right, chemical engineering, I remember that. So they do spin counter to each other. That like that's been the thing that like for I thought that would make them spin towards each other, but so far it makes them kind of like they've been traveling side by side or they've been orbiting. So like if I make them have equal strength, they're not going to mix. They're just going to kind of stay next to each other. Organic chem, I believe it. I only went up to Gen Chem, and that was enough for me. Vasan, hello, welcome in. So yeah, they're just kind of like traveling. They're not really. I don't know why they're doing that, to be honest. My favorite one that I made where they actually do collide, ironically, is when they have the same charge or the same like orientation. Where is it? Here. Like this one is my favorite one that I made yet. This one they have the same spin. And I feel like this is what they mean by colliding, but these are maybe eddies? I don't really know what the right term is, but I was in class we've been calling them like vortices, as in the plural of vortex. And I think this could be like hurricanes or whirlpools or kind of any fluid that spins, which eddies might also be, but I don't know. All right, these are oppositely charged again. This is one where I just generated a bunch of random ones and threw them all in. That's a tricky question for me, Helldog. I don't really have a specific goal. I just kind of like math, so I'm studying it. It's a problem for future me to figure out what to actually do with this. But yeah, I've kind of been randomly changing the values, hoping that eventually I'd strike gold. Yeah, it's Navier-Stokes. It's Navier-Stokes in two dimension with like the thin fluid approximation or whatever it's called. Um, and I'm numerically solving it with fast Fourier transform. You know, you may as well try Famished. Maybe he'll go for it. It doesn't hurt. Uh, that's an interesting question, Fun. I bet they would, because they have a different. I think they're gonna have a different equation governing them. Um, but it's kind of funny that we have gotten some kind of similar behavior as with gravity. Like we've been able to make someone like orbit each other. Uh, I don't know what you use to simulate black holes. Can find out. Oh, wait. This just kind of sounds cool. Quantum mechanics? No, I never did. Um, there are other streamers on Twitch who have. This isn't. I'm just kind of curious what this looks like. Ooh. Oh my god, that's so sick. The light is bending. Oh, is that? Oh, okay. I guess they're gonna explain now, but uh, yeah. Thank you, Hell Dog. If you're interested in math streams in general, I don't know if you know like the Twitch math community in general, but there's a whole little like niche of us who do this, and the list kind of keeps getting longer, as you can see. If you're interested in a chemistry, there's someone who isn't on this list who just recently started streaming who's very good with chemistry. JC. Yeah. There's also actually no, they're already on the list, but for quantum mechanics, uh, like you could talk to Ren Dio, who's on that list, Fizzbuzz, and maybe Actual Education. I don't remember. I don't know how much he's gonna remember of it, but I'm pretty sure he's at least done quantum mechanics at some point. Maybe physics and depression, but I don't know if he remembers it. Well, those are all the links there in chat. Um, I know it's a lot to like click through, but if you're in the Discord, I have them like permanently posted there too. If you ever want to like come back to it, like my computer has to be on, but you can always type exclamation point math streamers in my chat even if I'm offline. And as long as my PC is on, which is during like the American daytime, it'll pop up with the list. Oh yeah, I was just looking for like I think my music is looping. Let's switch up the music. I wonder. Let's just look at black holes Wikipedia page. Like, what equation do they use to model black holes? The no hair theorem? Yeah, I think the last time I streamed, you were one of the people who got one of the gift subs. Why is this the no hair theorem? I don't know. Got gifted one high potential stream. Nice. Gift subs are always nice. I feel like I get them in waves also. Because normally, like, I don't regularly sub to any streamer on Twitch. So in the channels that I frequent, I'm just kind of like a leech who hopes I get a gift sub. And I feel like I tend to get them around the same time. Oh my god, this page is so long. All right, you know, I can't easily find it. Well, ooh. Will my textbook have this? I feel like maybe they might. Um. Oh, there's no black holes? Come on. This... that's disappointing. Oh, what the hell? Why are we putting Kant? Ooh, the great philosopher Kant. I feel like the philosophy streamers here would have an issue with that. I say I don't know much about Kant, but I always hear him getting ragged on. The two egg yolks of event horizons don't spin, but the disks have to behave similar until the yolks meet, similar to vortex. Interesting. All right, see ya, Helldog. Thanks for saying hi. Yeah, honestly, I don't know enough about the physics of what I'm doing here to really speak about it knowledgeably, but yeah, I don't know. We could see if there's a mention. It's like, well, the thing I'm using is Navier-Stokes. We could see if there's a mention of this. For something involving black holes. Oh, to win the $1 million, you don't have to solve Navier-Stokes. You have to prove it has a smooth solution. That's so much easier. Let's go do that. Um, oh my god, cylindrical coordinates? Oh, that's a nightmare. Uh, does something get cut off here? Or does this mean R in citation 16? Okay, so yeah, I'm not sure how they simulate black holes. Maybe there is something from Navi or Stokes to use there, but I don't quite know. Um, this feels like maybe a natural place to call it. Because this one, I'm kind of stuck on this. I don't feel like doing other homework right now. Because I've kind of been doing... I've been productive for the past, like, 6 or 7 hours, and I kind of want to stop being productive for a bit. Um... Yeah, I think we'll call it here. So the scene, hey, I got it right on the first try. Yeah, I'm cut the YouTube stream off here, so nobody's here on YouTube. Thanks for being here.